This video is an introduction to stream flow analysis. The goal of this exercise is to create a stage-discharge relationship for a stream bed, allowing us to determine the flow or discharge if we know the depth or stage of the stream at the gauge location. We are at a park in the south of Durham in September 2020, where we are taking measurements to create the stage-discharge relationship for this stream. Notice the vegetation in the stream bed. One of the factors that affects the discharge, or the flow of water, is the surface on which it flows. If the stream bed is a smooth concrete, the flow will be faster than if the stream bed is full of roots and vegetation that disrupts and slows down the flow of water through it. Another factor that affects the discharge is the slope of the stream. So the first thing we do is measure the slope of the stream. We put 2 green stakes in the middle of the stream bed, one upstream from the other. We tie a piece of string to one stake and run the string to the second stake. We measure the depth of the riverbed from the string. But in order to be consistent in measurements to get slope, we need to make sure that the string is level and the stakes are vertical. We use a level against the stake to make sure they are both straight up. We don't have the right level today, so we are using a plumb to make it as vertical as possible. We hang a level on the string and adjust the strings on the stake so that the bubble is in the center of the level. Once we have the string at the same elevation for both stakes, we hang the plumb from the string. The plumb should just touch the bottom of the stream bed. Then we measure the length of this string with the plumb. This string length gives us the depth of the stream bed from a set point on the stake. We repeat this process for the stake downstream. Since we are measuring the depth of the stream from the same height at both stakes, which is the horizontal string between the 2 green stakes, when we get back to the classroom, we will manipulate this data to get the depth of the stream at each end. This will be the rise in our slope equation. To get the run of our slope equation, we measure the length of the riverbed between the 2 stakes. We use this measuring wheel. To start, we make sure that the measuring wheel is zeroed out. Then we place the measuring wheel at one stake and roll down the center of the stream bed, maintaining contact and keeping the wheel in the center of the stream bed until we reach the second green stake. This measurement will give us the length that the water travels in the stream and is the run of our slope equation. Another factor that affects the flow of the water is how deep the water is. For this analysis, we measure the depth of the water at several locations along the river. To do this, we put a pair of stakes on either side of the stream at each measurement location. We want to space the pair of stakes evenly between the green stakes. We are choosing 4 locations to do measurements. If you want more accuracy, you can do more measurements, it just takes more work. These 4 locations become our gauge locations. Once we complete the analysis, we'll be able to estimate the discharge at the green stake downstream by measuring the depth of the water at any one of these 4 locations. The riverbed is not the same depth across the entire bottom. Typically, it has its shape more like a trapezoid. So rather than measuring just one depth at each stake location, we measure the profile of the stream at each of these 4 locations. To do that, we start by putting a string across one pair of red stakes as a reference point. Again, we want to make sure that the string is level, so we attach the level and adjust the strings until the bubble is in the middle of the level. We measure the distance between the 2 stakes, which we can see is 36 inches. To get the profile of the stream bed at this stream cross-section, we measure the depth from the string to the bottom of the stream bed, and then manipulate this data in the classroom to get the actual profile. Since we want the profile and not just the depth in the middle of the string, we will divide the length of string into equal parts. Here we have chosen 6 inches as our distance between measurements. The smaller the distance between measurements means more accuracy, but it's also more work. As an engineer, it's your job to determine what accuracy is needed. We could be here all day if we measured every centimeter, but is that level of accuracy needed? At each mark on the string, we hang the plumb so that it just touches the bottom of the riverbed. Then we use a measuring tape to measure the length of the string and record it. We continue to do that for each mark. It is very important to note the direction of the stream. Right now we are looking downstream and measuring from left to right across the stream bed. Once we finish with measuring the depth at each 6 inches along the string, we move to the next set of red stakes and repeat the process. It's important to be consistent in the way we measure and record the data. Since we started from left to right looking downstream, we measure from left to right facing downstream at all of the red stakes. Once we have all of the data, we use this data to create the stage-discharge relationship for this stream bed. You will be given a set of data that a previous class collected to do this analysis. When the analysis is complete, you will be able to estimate how much water is flowing at the downstream stake by measuring the depth of water at any of the locations where the red stakes were located. As mentioned at the beginning, one of the factors that influences the flow is the roughness of the riverbed. This is a value called Manning's number that we estimate based on empirical data. We will look at tables to do this back in the classroom, but you need to remember what the stream bed looks like in order to be able to estimate this number.